So there's some rules that we want to kind of try and follow when we consider this difference of two perfect cubes. In the space at the right, show how to write it in a factored form using words, arrows, colors, or the other visual tool so that you can explain. So I'm going to try and give you those tools to sort of explain. We have from yesterday's worksheet the general form, and I'll even write that here, a squared minus b squared cubed. Those are both cubes. That'll factor. The first set of factors here is going to give you the cube root of each of them. And it's easy to kind of see that, well, I don't know if it's easy or not, but we see that an A is still an A and a B is still a B. This is the cubed form, and this is the non-cubed form, the cubed root. So it might be easy to see this, but it translates differently when you start using numbers. That term squared gives you an A squared. That term squared gives you a b squared. And so that's the first and the last term. This will always be a plus, and this sign will always be the opposite of that. So these will be opposites. OPP. All right? Every time. So these will always be the same. So that and that should always be the same. So if this is a minus, that's a minus. If that's a minus, that's a plus. However, the middle term here is the product of these two. So even though it's AB, and normally we would say an A times a negative is going to be a negative, but it's not that we're multiplying that times that. It's whatever value this is times whatever that value is goes here, but the sign is opposite. Okay? So when we look at this, the factored form, the first set of parentheses, it's the cubed root of this whole term. Now there's two parts to it. There's a number and there's a variable. If we do them separately, the cubed root of 27 is 3, and the cubed root of x cubed is x. It's described up here, that's a minus, so therefore this is going to be a minus. And the cubed root of 1,000, it's a 1 with 3 zeros, is 10. Okay. We have a binomial followed by a trinomial. The trinomial is simply a matter of pieces and parts of this thing. So now that we're done with this, we don't have to even look at that again to be able to come up with this. So as we showed here, you take that term and square it, and you get a squared. You take that term, the entire part of it, two parts, square it, you get a 9 and an x squared. You don't have to FOIL anything necessarily because it's a single term with a product of two things. Okay. So the next thing you do is this product of the middle two things. However, if that's a minus, then this is going to be a plus. Again, that was a minus because that was a minus. And because that's a minus, that's a plus. I'll give myself more room here to maneuver. I've got space. So anyway, I take the product of 3x and 10. Well, that's a 30x. And yes, 30x times negative 10 would give me a negative, but it's not about that. It's about the product of those two numbers and make sure that that sign is different than that sign. The last term over here is always going to be a plus because it's negative. It's just always going to be a plus. And in this case here, it's a 10 squared, which is 100. So little things that you can kind of say to yourself, always a plus. These are always opposite. Okay. This term squared. And then if you take this and put it over here, it's that term squared. And then this is the product of the middle two product. So the sign is opposite. This is the product of the first two, and each of these first and last are the first and last squared. All right. So if we look at that, well, that's good. We'll do some examples in a second.